In this second block of topic 18, we're going to learn the equation of a circle, and we're going to develop it using the distance formula. So just like in algebra, you studied how to write the equation of a line, we're going to learn how to write the equation of a circle. So an equation of a line, remember, describes every point on a line, and there are infinitely many points on a line. And that's why the x and the y in the equation are there. They are representing every single point on that line, and there are infinite number of them. So if you ever wanted to know if a point was on a line or not, remember you could just substitute it in for the x and y in the equation and see if it makes a true statement or not. So for example, if I wanted to know if the point 1, 5 is on this line, I would put 1 in for x, 5 in for y, and see if it's true. Well, 2 times 1 is 2, plus 3 is 5. So that tells me the point 1, 5 is one of the infinite points on this line. Likewise, when we write the equation of a circle, we're going to have an x and y representing every single point on that circle. And again, there are infinitely many points on a circle. So what pieces of information do you think would be useful in describing a circle? This is just a list of different applications of circles in the real world, and these you can read through them if you'd like to. Some of them are like when an earthquake occurs. We know the seismic waves radiate out from the epicenter, which is the center of the earthquake. And so that is a circle application in the real world. In a school district, number 5 here, students can ride the bus to school only if they live outside a certain radius of the school attended. So like if you're outside of a half-mile radius, well, you're creating a circle around the school of students that would not be able to ride the bus. So just remember that by definition, a circle is a set of all points in a plane that are a given distance from a given point in that plane. Well, the given point is the center of the circle, and the given distance that all the points are from that center is the radius length. And so because this definition uses distance, we can actually use the distance formula to help us learn the equation of a circle. So it's important that you know the distance formula. That's number 1 in your notes. So if you have not memorized that, you need to go ahead and put that in your notes now. One thing to note is that Agile Mind has the formula as x sub 1 minus x sub 2, and you might see the formula written x sub 2 minus x sub 1. It really does not matter what order you put your subtraction in, since you're going to square that answer. So remember, by squaring, you make that thing, that whole difference become a positive number. So it doesn't matter the order you subtract your x coordinates or the order you subtract your y coordinates. So these are some things to ponder about with circles. Why do you think the distance formula will be useful when we're finding an equation for a circle on a coordinate plane? And what in the definition of a circle might connect the distance formula? So look here, the given distance is what we're looking at, which is your radius, from a given point, which is the center. So that is important information in that definition. All right, so let's look at our animation that is going to get us the equation of a circle. So this circle right now is not on a coordinate plane, but they're going to put it on there and make S at the origin. So that's the point 0, 0. We can easily tell the radius of the circle since we have this horizontal distance to a point on a line. We can simply count those units. And so we see that point R is at the point 3, 0, which is 3 units away from 0, 0. So we know our radius is 3. We know the center of the circle is 0, 0. And we are just going to look at a generic point on the circle. So they moved R from 3, 0 just to some random place on the circle. So our radius is still 3 because the radius is the same the entire distance around the circle. It doesn't change. Our center is still at 0, 0. But we're just going to call point R as having coordinates x, y, so just generically. So we're going to actually put the distance formula in to represent that radius distance, which is the distance between points S and R. So we're going to substitute in our x coordinates as and y as r, and then 0, 0 as our other x and y into the distance formula, and simplify that. X minus 0, of course, is x, so that's x squared, and y minus 0 is y squared. At this point, we would not leave the equation looking like this. The last step would be to get rid of that square root symbol by squaring both sides. And so we are left with x squared plus y squared equals 9. This is the equation of this circle. X squared plus y squared equals 9. So we're going to look at some different circles. Here's one centered at the origin with a radius of 2, centered at the origin with a radius of 1. And so we should be able to tell a pattern now. So hopefully you see that when the radius was 3, we had a 9 over here. Radius was 2, we had a 4. Radius was 1, we had a 1. We are squaring that number. And so this is the general form for an equation of a circle when the center is at the origin. So let's make sure that we have our notes filled out here. Remember, the coordinates of the center were 0, 0. How could you describe the coordinates of r as it moves around the circle? We're just going to label it as a generic point. We know the distance from S to R is 3, which is our radius. And we could tell that from here, that horizontal distance. And so we wrote the equation of the circle as x squared plus y squared equals 9. You can go through and show that work from the animation if you'd like to replay that and make sure you get that down. But this is the simplified version, which is the equation of that circle. All right, so we have a generalized equation for a circle, but remember, this is only if it's centered at the origin. And of course, a circle can be centered anywhere, not just at 0, 0. So how would the equation be different for circles that are not centered at the origin? Go ahead and try to answer questions 3 through 6 in your notes, and then we'll come together to look at that. All right, so this is what you have for 3 through 6. We're supposing we have a circle now that the center is at a different place besides the origin. In this case, the circle we just looked at has been translated 1 unit to the right and 2 units up, so its center is at the point 1, 2. We still have a radius of 3, just like we did in our previous problem. We can see that with this horizontal distance here between the center and this point on the circle. So by the definition of a circle and the distance formula, and because segment AB is horizontal, that's how we know what the radius is. It's the distance from point A to B, which is only 3 units. So that's what you should have had in that first blank. It says, by the definition of a circle and the distance formula, we know the radius is also AC, right? So that radius is going to be the same as you go around the circle. So we know this is also going to be 3 as well. So we can set 3 equal to the distance. Okay, it is the distance from point A to C. So we're going to put these coordinates in the distance formula. So the one that shows that correctly is this option right here. It's the square root of the change in x, that's x minus 1 squared, plus the change in y, that's y minus 2 squared. So squaring both sides of the equation will get rid of that square root. So the radius over here that was 3 becomes a 9. And what was underneath the square root symbol comes out. It just doesn't have the square root anymore. So this is the equation of the circle that is centered at 1, 2 with a radius of 3. So notice in the equation, the center is positive 1, positive 2. But look in the equation, they have subtraction signs in front of them. That's going to be very important. This is still my radius squared out here. So now let's look at generalizing this process. Instead of having a specific point and a specific radius, what does this look like in general terms? So let's look at the next animation. So it says the distance between 2 points, we already know the formula for that is shown here. we're going to let d equal r, which is the radius of our circle. And so the x sub 1 minus x sub 2 can be replaced. If we look up here, these are the 2 points that we're talking about, the distance between, that represent our radius, between point A and between point C. They've strategically labeled A as the point HK, and C is any point on the circle is XY. So how would we represent that change in X? It would be X minus H. So that's what you should have here. For the change in the Y coordinates, my Y coordinates are Y and K. So we would write that as Y minus K. So now we can put that into the distance formula and square both sides. So this is what it would look like in the distance formula, but it told us to go ahead and square both sides. So that r becomes r squared, and what's underneath the radical comes out when we do that. So this is the general form for the equation of a circle. This is what you will need to memorize. X minus h squared plus y minus k squared equals r squared. So that's the general equation for a circle, just like y equals mx plus b is the general form for the equation of a line. Now, when you draw a circle, it has 4 special points that you use to graph it. So here is a circle centered at 1, 2 with a radius of 3. And to draw that circle, we can go out 3 units from the center to the right, to the left, up, and down. These are our 4 best points for locating the radius, because that gives us a horizontal distance or a vertical distance that can be simply counted. So let's look at question 10 in our notes. It says an equation for this circle is x minus 1 squared plus y minus 2 squared equals 9. Do the points with the coordinates 4, 2, negative 2, 2, 1, 5, and 1, negative 1 satisfy the equation. So just like we do with points, if we want to know if a point is on a circle, we're simply going to plug it in for the x and y in the equation and see if it makes it a true statement. So if I put the point 4, 2 in, I would have 4 minus 1 squared plus 2 minus 2 squared equals 9. So I put 4 in for x and 2 in for y. So 4 minus 1 is 3, so that would be 3 squared. 2 minus 2 is 0, and we can see that that is true. This would be 9 plus 0, which is 9. So this point is on that circle. Go ahead and pause the video here and go ahead and check the other 3 points. Okay, so once you plug those numbers in, you should have gotten that all 4 of these are indeed satisfying the equation and are on the circle. So let's review what we learned today. What is the definition of a circle centered at A, HK with a radius R? So by definition, a circle is a set of all points that are a given distance from a given point. And so the definition of a circle with this center and this radius is the set of all points that are r distance from the point HK. So it's a set of all points that are a given distance, that's your radius, from a given point, and that's the center. So in this case, that was HK. The general form for the equation of a circle that you need to have memorized is x minus h squared plus y minus k squared equals r squared. So this is always the radius squared. So if you are given an equation, x minus 3 squared plus y plus 5 squared equals 36, you should be able to tell me the center and the radius. So the center, remember, the equation has subtraction here. So the x and y coordinate actually is the opposite sign of what's in the parentheses. So the center of this circle would actually be a positive 3, negative 5. The radius is being squared, so you'd have to take the square root of that to know that my radius is 6. So looking at an equation, we should be able to identify the center and the radius. All right, that is it. Good luck with your homework.